In this screencast, we are going to extend our understanding of expressions from numerical expressions, which are expressions that only have numbers, to algebraic expressions, which are expressions that have at least one letter or variable and possibly a number in one number. As you can see, I have let me fix that. So I have some expressions here. X plus 3, again, an expression is made up of one or more numbers and or variables or both. So in this case we have x plus 3. So when it says to evaluate an expression, what it means is you're going to simplify or solve for this by replacing the variable with the number it says in this case, or you can put in your own numbers when we come over to this side. So in this one we have x plus 3 for x equals 5. So that means that we're going to replace x with the number 5. So x plus 3 becomes 5 plus 3, which equals 8. So some of these are not very challenging, but they do get more difficult as we move down, especially a third one. But again, when it says evaluate, it just tells you that you're going to replace the variable with a number. These aren't equations. This wouldn't be like x plus 2 equals 6, where we're solving for x. That's an equation. The difference between an equation and an expression is an equation can be solved for one number, but an expression, since there's not an equal sign, we're not looking for a specific number. You can basically put any number in you want, but in this case it's telling you that. Alright, so we can move down to the second. We have 3 times parentheses x minus 2 parentheses plus y. So I'm going to circle just because we're going to do this and this. I'm going to circle the two terms. I didn't on the first one since it was easy, but in this case I did. So we're going to replace x with 4, so I'm going to rewrite it to be 3 times parentheses 4 minus 2 parentheses plus the y is just going to be 2. So this is just 2. This one we need to simplify. So we have a multiplication and we have a subtraction within parentheses. Order of operation again is PEMDAS, P, E, M, D, A-S. Parenthesis means that we're going to do this first. So the first one we're going to do is 4 minus 2, which is 2. And then that means that, and we're going to multiply that by 3 to get 6. So this term here becomes 6. That term was 2. 6. Put a line here so you can see it. 6 plus 2 equals 8. So that is 8. Alright, now over here we have 3 terms. We have, let's change colors for yellow. 5 by itself, x squared by itself, and we have y squared by itself. So we're going to replace the x and the y with 3 and 2 respectively. So 5 is by itself, plus sign moves down, x squared becomes 3 squared, and then minus y squared becomes 2 squared. So now we have 5 plus 3 squared is, remember, the base times itself that many times 2. So that's 9. And we're going to subtract 2 squared, which is 2 times 2, which is 4. Now we have addition and subtraction from left to right. 5 plus 9 is 14. 14 minus 4 is 10. Hopefully you're noticing that I'm showing a lot of my work. The reason being is, 1, it's easy to tell where you make a mistake, and 2, you're not going to forget or skip anything. So you should be able to see all of your steps. So that's the answer for this problem 10. So when we evaluate expressions, if they tell you what value to replace the variable with, you just plug them in and you do order of operation. So it really becomes goes from an algebraic expression, like the purple, to a numerical expression, like the green and purple. Algebraic expression changed to numerical expression. You might also see it like this, where you're given x plus 5, but you're not told what value to put in. A lot of times you'll make a table. You'll say, okay, whatever I put in for x, what is x plus 5 going to be? So if I put in 0 here, that means I'm going to put 0 in for x, and if I change x to 0, 0 plus 5 is 5, so that would be this 5. If I plug 1 in for x, it means I have 1 plus 5 equals 6. It would be 6. If I put 10 in for x, 10 plus 5 equals 15. In this case, dot 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 means we can put in any number we want to, even negative numbers when we get used to using those, and we can solve for any number to get it, because it's an expression and not an equation. So again, as a review, algebraic expressions are expressions that have variables and or numbers, and we're going to be asked to evaluate, which means to replace the letter or variable with a number, or you're going to be given an expression and you have to solve for what possibly could be answers depending on what the letter is for x.